My name is Brian Larkowski, and I am the General Manager of H3. We distribute Zehnder ventilation systems in the southwestern United States. We're currently focusing on new ventilation strategies for multi-unit, multi-story buildings. Many architects and developers are turning to high-efficiency heat and energy recovery ventilators to conserve energy and provide a balanced system of supply and exhaust air to enhance indoor air quality. This is admirable and necessary as these systems deliver continuous fresh air regardless of climatic conditions. A typical layout we see today requires one HRV or one ERV for each living unit. These tend to be compact, smaller units that mount above the ceiling in bathroom or closet areas. In some cases, designs like these are the best option, but in others, there may be better options. We need to consider the building design and the following. Individual smaller HRVs typically require an exhaust and supply penetration in the outside wall for each unit. Smaller units have smaller heat exchangers, and this results in diminished efficiency levels. When HRVs are located within the occupied space, sound attenuation can become a factor. Occupants have been known to turn off noisy systems, so this is a serious issue. Compact units required to fit in these spaces tend to be more expensive with lower efficiency, as smaller HRVs have smaller heat exchangers. Smaller heat exchangers deliver diminished efficiency. Maintenance requires periodically entering each and every occupied unit to change filters and maintain equipment. This is inconvenient for occupants as well as maintenance, and ultimately results in higher operating costs. Due to reduced efficiency levels of smaller HRVs, power bills will be higher for both HRV and conditioning systems, not to mention wear and tear due to excessive cycling of equipment. We've been researching other options that address a number of these issues. This new strategy revolves around using a single HRV to serve multiple units. For example, let's say we supply 3 back-to-back occupancies with one larger HRV. This still provides localized control. It improves efficiency as well as significantly driving down initial costs. 3 smaller low-efficiency HRVs are more expensive than one larger high-efficiency HRV. What if we placed equipment in a common space that was directly accessible to maintenance and did not disturb the occupants? This would improve service as well as reducing costs and occupant disruptions. Maintenance is reduced due to conveniently maintaining one device versus maintaining 3 individual devices. By placing the HRVs outside of living spaces, we better address sound attenuation, and using a higher quality unit addresses this even further. By consolidating units, we reduce outside ducting penetrations by about 1/2 to 2/3. This further reduces costs. This might sound like an infomercial, but that's not all. With the advent of technological advances, we now have wireless capabilities, bus-style communication, and an app for maintenance staff. They can monitor performance, make adjustments, and receive app-based alerts when filters require changing. These new units have vastly larger heat exchangers that provide a whole new level of efficiency, up to 96%. The Q units can communicate with other synergistic systems, such as advanced conditioning and dehumidification. There is an options box that allows for a number of additional connections. In many cases, there can be confusion as to left and right units. Proper handing typically makes it easier for the installer to connect ducting. These new units are reversible, so with a couple touches of the app, we can change the handing to best suit specific installation parameters. By instituting this new strategy, coupled with advances in Zehnder-related technology, we now have the ability to reduce both initial expenditures and operational costs. The occupant receives better air quality for less money. They enjoy the effects of improved sound attenuation. Their conditioning equipment cycles less frequently, so it lasts longer. Systems that run less generally require less maintenance. Maintenance of the units is further reduced as there is less equipment to maintain while still allowing for area-specific system control. We have to remember the primary reasons for adding heat recovery ventilation. They are heat recovery and ventilation. Ventilation is somewhat of a given. We need X number of CFM to properly ventilate the space. Most folks understand that heat recovery is directly related to efficiency level, and that this is a critical metric when it comes to conserving energy. What we don't necessarily consider are the effects of unlike air temperatures and their ability to diffuse readily. If we have a 40-degree day in winter and we have a 70-degree interior temperature, the delta T is 30 degrees. If our unit provides 90% efficiency, air is returned at 67 degrees. With a 3-degree difference, the air streams readily diffuse, creating comfort, enhancing indoor air quality, saving energy, and reducing cycling of conditioning equipment. If we take the same delta T of 30 degrees and look at a unit that provides 70% efficiency, the air returns at 61 degrees. With a 9-degree difference in temperature, air streams do not diffuse readily, and stratification can become a factor that adversely affects blending of streams, indoor air quality, and comfort. The reduced efficiency results in higher energy costs and increased cycling of conditioning equipment. In review, if we look at all of the advantages of this proposed ventilation strategy, I think we would all agree that it is worthy of further consideration. Advances in equipment play a large role, and by changing our design methodology, we can achieve some amazing results. The things shown in this slide are just a part of what can be gained in adopting a new way of thinking. We have to remember that these systems address ventilation, not conditioning. They run extremely efficiently 24/7 and do not need to be adjusted by occupants, with the exception of boost switches in the bathroom areas. This means that independent control is not required. It also prevents occupants from inadvertently turning off the fresh air supply. At this point, I know what many of you are thinking. What about firewalls? Can we even do this? How do we work within codes to make this possible? These are great questions, and we have researched a number of codes and code exemptions relating to the strategies we are proposing. The strategies primarily relate to running ducts horizontally, not floor to floor. As each project varies and exceptions are based upon these variations, we would prefer to review preliminary plans and propose the most viable code compliant solutions. We are also open to discussing projects and strategies, even if no preliminaries exist. We have also received a number of questions relating to rooftop dedicated outdoor air systems. These systems are generally larger units that can provide higher volumes of outdoor air to high occupancy spaces. A DOAS is well suited to replacing existing systems when ducting is already in place to provide a less invasive solution. These systems typically originate at the roof level or an outside slab and are exposed to the elements. To ventilate multi-story occupancies, they require vertical chaseways and ducting, resulting in the need to push volumes of air through longer expanses to reach the final delivery point. Using a number of interior-based HRVs makes more sense in many cases, as they are located inside of a protected and insulated space. They do not require floor-to-floor chaseways or the fire-related challenges or expensive dampers that exist in ducting from floor to floor. Adjustments can be made on a smaller scale relating to the needs of west side versus east side, as well as microclimate zones and other climatic factors. On the other hand, a DOAS can be a great solution for a gymnasium, conference center, lobby, or warehouse, as they conduct the air directly or semi-directly in large volumes required for such spaces. In any event, these units are outside the scope of what we provide. We'd like to thank you for taking the time to view our presentation. We would be happy to discuss project-related specifics to help you design a state-of-the-art ventilation solution that optimizes the budget and system performance, as well as enhancing occupant comfort and health. Please contact David Green, Zehnder Regional Manager for H3, 805-696-3378, or you can email David at goh3.com. Thank you.